This meeting is being recorded.
In problem 8 from chapter 4, we're asked to provide the systematic name for each of these compounds. So we're going to be following the IUPAC rules. So we won't have to worry about common nomenclature for these questions. But we're going to follow this kind of a 4-step plan down here listed. So first we're going to identify the parent. Then we're going to go back and identify any substituents. We'll assign the location or locant for each of those substituents. And then in step 4, we will alphabetize those. So that's our process here. So let's take a look at compound A. And we start over here. And 1, 2, 3, 4, 5, 6. Now, if I went down, I would only have 7 carbons. But if I went up, I'm going to have my octane parent. So that's step 1. Step 2, identify substituents. So I have 3. I have collectively, these will be trimethyl substituents, and I have them on carbons 3, 4, and 6. So if I pulled this all together, we would end up with a 3, 4, 6 trimethyl octane. So we're going to do something similar here with compound B. This parent is a cyclic structure. So we have our 6-membered ring over here. So we have a cyclohexane as our parent, and then we only have this one substituent. So if we follow the IUPAC nomenclature, if you recall, this type of side chain would be a 1-methylpropyl substituent. The common nomenclature for this is a sec-butyl group. So we'll name this using only the IUPAC rules. So we would call this a 1-methylpropyl cyclohexane. Similarly, we could call it, instead of that, a sec-butyl cyclohexane. Let's look at structure C now, and I'll start, how about down here? So I have 1, 2, 3, 4, 5, 6, 7 carbons. So I have a heptane parent. And then I have this ethyl substituent and this methyl substituent. So I want the lowest numbering overall for my substituents. So I numbered them this way, because if I started at the other end, I would have like a 5 and 6 locant for my substituents. But instead, I have a 2-methyl, and I have a 3-ethyl substituent. So now I have my parent, I have my locants. Now I need to alphabetize these substituents. And we haven't had to do this before because in the first example, they were all the same. And in the second example, we only had that one substituent. So now what comes first alphabetically? Ethyl would. So this compound, the overall name, I'll write up here. This would be a 3-ethyl, 2-methyl, and then our parent, heptane. Let's take a look at compound D here. So again, we could name substituents as common names or as IUPAC. So we'll do the IUPAC route. So our parent here we'll find is a pentane. So I'll start here, 1, 2, 3, 4, 5. If I went up, I would also have the same number of substituents and the same parent. So we have 5 carbons, we have a pentane parent, we have 1, 2, 3 substituents. So these are methyl substituents. Up top here, our IUPAC would call this a 1-methyl-ethyl substituent, or in our common nomenclature, we could call it a isopropyl group. But for our purposes, we'll stick with the methyl-ethyl. Now we have to assign our locant. So I'm going to switch colors here so we can clearly see. So if this is carbon 1, 2, 3, 4, 5, I have a 2, 4 dimethyl. And this would be a 3,1-methyl ethyl substituent. So if we were to tie this all together, we need to alphabetize these substituents. So what we see is that we would list the dimethyls first, and then our methyl ethyl second. So we would call this guy in IUPAC nomenclature as a 2,4-dimethyl dash 3 dash 1-methyl ethyl, and then this would all be one word if I had enough room, pentane. So see if you can try the remaining problems using the same technique. Identify the parent, identify substituents, assign locants, and then alphabetize those substituents.